Hi and welcome to Vulkan from Zero to Hero.
In this section, we are going to draw our first triangle. In this video, we are going to create window surface.
Welcome back. In our previous videos, we created Vulkan instance and Vulkan device successfully. Now it's time to create window surface. I'm going to create another structure, namely output underline presentation underline window. And this structure should contain some information about presentation window, such as full screen status, aspect ratio, screen width and height. Actually, aspect ratio is the ratio of the width to the height of a screen. We need to store window handle, HWND, and window instance, which is a type of H instance. If we want to build this code on Linux, we should use XCB connection and window. Given that we are using Molten VK on Apple and iOS, then we should use a void pointer, and for Android, we should store pointer to a native window. Actually, VSync or vertical sync is a display option that allows the game to synchronize the frame rate with monitor refresh rate for better stability. We need a boolean variable in order to store double buffering state for swap chain. Okay, we need to store presentation surface, which is the type of VK surface KHR, and selected format for swap chain, which is a type of VK surface format KHR. The Vulkan object swap chain, and a vector for storing swap chain's images. I'm going to declare image underline view structure later. Also, we need the current index of swap chain's image. It is needed when we are going to use double buffering swap chain. We need to store all surface formats. A depth buffer, which is a type of image underline view, and finally two semaphores that we will use for synchronizing. First for checking when the swap chain is ready, and the next one will be used whenever the swap chain has done its rendering job. Let's create image underline view structure. This structure contains VK image and width, height, and the format of the Vulkan image. Because each image needs a memory for its buffer, so we should declare memory flags for this image. Let's set the default value vk underline memory underline property underline device underline local underline bit. This flag means the memory will be hosted in GPU. We need a Vulkan memory object, an attachment description, and an attachment reference. Okay, now let's add an instance object of output presentation window to device class. Go to the device manager.cpp and here let's store the inputted presentation parameter into the present window of device. Make sure to enable double buffering and store the window information based on the platform. We've already defined this in graphics header. For example, on Windows, we need H instance and HW objects. In order to create an object from VK display surface creating for KHR structure. On Linux, if we are using XCB library, then we need to use XCB connection and XCB window object. Or if you are using xlib library for window handling on Linux, then we should use display pointer and handle of xlib. For molten VK, we use void pointer for passing window information to the surface creating for. And finally, on Android, we need a native window object. Now, by having Vulkan surface, you can create swap chain. In the next video, we are going to create Vulkan swap chain.